Assalamualaikum and a good day everyone. Today we would like to present a video about transitional metals and coordination compounds for the subject CHM361. I am from class A4AS 120511. Enjoy. Now before we start the video, let me introduce you to our group members for today's video. This handsome yet elegant young man is yours truly. Thank you. My name is Said Wafi Al-Hadi bin Said Zain. And this beside me, the man with the sweet smile, his name Muhammad Faris Faik bin Muhammad Faizan. Next is this young man with a masculine pose. His name is Irfan Damien bin Muhammad Fauzi. And lastly, this pretty boy. His name is Irfan Nazmi bin Muhammad Nasir. Now that the introductions is complete, let's jump into the video. So, what will you be learning in this video? These are the four objectives of the video. Firstly, you will know how to define transitional metal and coordination compounds. Next, you can explain the unique properties of transitional metals. After that, you will be able to list the contents of coordination compounds. And last but not least, you can apply the use of transitional metals and coordination compound in real life. Now that you know what to learn and what to expect, let me start with the introduction to this topic. Transition metals are elements that are located in the D block of the periodic table. These elements are characterized by having partially filled d orbitals in the atoms or ions. Due to this unique electronic configuration, transition metals exhibit a few distinctive properties that you will learn later in this video. One of which is that many transition metals bind with ligands to form coordination compounds. As such, transition metals and their compounds play important roles in industry, medicine, and biological system. Therefore, understanding transition metals and coordination compound is crucial in the study of inorganic chemistry.
First of all, let's go to the transition metal. Transition metals are elements that located in the central block of the periodic table. These elements occupy group 3 to 12 and have partially filled d orbital in their atomic structure. And properties of transition metal are like S and P element transition. Metal can exhibit a wide range of oxidation state, making them highly versatile in chemical reaction. As you can see that metals play a big role in a periodic table. So I'm going to talk about four unique properties of transition metal. The first one is multiple oxidation state and chemical versatility. The second one, high melting and boiling points. Third one, complex ion formation. And the last one is formation of color compound. Let's go deeper to the first two, which is multiple oxidation state and chemical versatility, and the high melting and boiling point. For the multiple oxidation state and chemical versatility, one of the most defining features of transition metal is their ability to exist in multiple oxidation state. Oxidation state differ to the change an atom who have it all bond in a compound were ionic. Transition metals can change their oxidation state by losing different number of electrons from their d orbital and s orbital. This flexibility allows them to form a wide variety compound and engage in numerous types of chemical reaction. For example, iron, Fe, a commonly non-transition metal, can exist in oxidation state, which is Fe2 plus or Fe3 plus, while copper can exist in copper 1 plus or copper 2 plus. For the high melting and boiling point, transition metal generally have high melting and boiling point compared to the other element. This is due to the strong metallic bonding that occur between the metal in a transition metal. Electrons are not confined to individual atoms but are free to move to the metal, creating a sea of delocalized electron. This electron contribute to to the strong metallic bond that hold the metal atom together, requiring a large amount of energy to break the bond and convert the metal from liquid to gas. For example, tungsten W. A tungsten metal has a high melting point, which is around 3422 degrees Celsius, making it the highest melting point. Go to the other two, which is the complex ion formation and the formation of the colored compound. For the complex ion formation, another hallmark properties of traditional metal is their ability to form a complex ion. A complex ion consists of a central metal atom or ion bond to one or more ligands, which are atom, molecule, or ion that donate electron to the metal. The ligand interact with the metal ion through coordinate covalent bond, where both electrons in the bond are donated by the ligand. For example, commonly complex ion tetraamide copper 2+, where copper is 2+, is surrounded by 4 ammonia molecules. The interaction between the metal ion and ligand gives the complex ion unique chemical and physical properties, including its stability, solubility, and reactivity. For the formation of colored compound is another fascinating feature of transition metal is the ability to form a compound that are vividly colored. This occurs due to the unique behavior of electron in the partially filled d orbital of transition metal. When light strikes a transition compound, electrons within the metal ion are excited to higher energy level. The energy difference between this level corresponds to the specific wavelength that are absorbed. The remaining light is reflected, giving the compound in characteristic color. For instance, copper 2 sulfate is a blue due to the absorption of specific wavelength of light, while chromium compound can produce a range of color from green to red. The ability of transition metal to form color compound is crucial in several fields, including chemical, where it's used in analytical technique like spectroscopy. In everyday life, this property is used in the production of dyes, pigment, or even gemstones.
And now we can go through for the interaction of coordination compound. Now, coordination compounds are chemical compounds that consist of a central metal atom or ion bonded to surrounding molecules or ions known as ligands through coordinate covalent bonds. In these compounds, the ligands donate lone pairs of electrons to the metal, forming a stable complex structure. Coordination compounds are commonly formed by transition metal and play an important role in many fields such as chemistry, biology, medicine, and industrial processes. And may I add some of the introduction that I not add in here. These compounds show unique properties such as different colors, magnetic behavior, and reactivity, which depend on the type of metal and ligands involved. Coordination compounds play a very important role in many fields, including chemistry, where they are used as catalysts, biology, such as in hemoglobin and enzymes, medicines, for example in anti-cancer drugs, and various industrial processes. Therefore, understanding coordination compound is essential for studying both theoretical and applied chemistry. And next, we can go to the what can we find in coordination compounds. In coordination compound, you can find the following components. The first one is central metal atom or ion, usually a transition metal, as you can see at my left side of the picture. We can see that is a central metal atom. The second one is ligands, molecules or ions that donate lone pair electrons. And the third one is coordinate covalent bonds between the metal ligands. And the fourth one, coordination number of ligands attached to the metal. And overall charge of the complex, neutral, positive, negative is the last one, that what can we find in the coordination compound. These features together determine the structure, properties, and reactivity of the coordination compound. We move to discussion for coordination compounds. Coordination compound consists of a central metal ion surrounded by ligands that are bonded through coordinate covalent bonds. The interaction between the metal and ligand strongly influences the compound structure and properties, as I said before at the introduction. By varying the type of metal ions and ligands, coordination compounds can exhibit different coordination numbers and geometries such as octahedral, tetrahedral, or square planar, and many more. These structural differences affect important properties including color, magnetic behavior, and chemical reactivity, as I briefed in the early introduction. Coordination compounds are widely studied because of their significant roles in biological systems, industrial catalysts, and medical applications, making them an important topic in inorganic chemistry.
Hello everyone. So next up, I'm going to talk about the application of transition metals and their coordination compounds. So these compounds are not just important in chemistry. It is also play a huge role in industries, medicine, technology, or even in our bodies. So let's take a look at our first point, catalysis. Transition metals and their complexes will act as efficient catalysts in many industrial reactions. For example, the Haber process, which produces ammonia for fertilizers, it is use metal catalysts to speed up the reaction. Similarly, catalytic converters in cars rely on metal complexes to reduce harmful emissions. So catalysts like these make process even faster, more efficient, and environmental friendly. So for our next point, which is biological system. Next, transition metal complex are essential in biological system. Take iron in hemoglobin, which is a metal complex that carries oxygen throughout our bodies. This shows that coordination compounds aren't just chemicals in a lab, they are vital for our life. So for the next point, which is medicine. In medicine, these compounds are extremely useful because these compounds are commonly found in medical imaging, chemotherapy drugs, and diagnostic agents. For instance, certain metal complexes improve the clarity of MRI or target cancer cells for treatment. So for our point number 4, which is industrial process. In industries, coordination compounds have many applications. They are used in electroplating to coat metals, in making alloys, and to preventing corrosions. These applications help to improve durability and efficiency in manufacturing and construction. So for the next point is environmental applications. So it is also very important for the environment. Metal complexes will help to detect pollutants, treat wastewater, and manage chemical waste. By using these compounds, we can make industrial process safer and more sustainable. So finally, in materials and technology, transition metals complexes are indispensable. They are used in pigments, dyes, batteries, and advanced material because of their unique electronic properties. This makes them key in developing modern technologies. So next up is the conclusion. In conclusion, transition metals and coordination compounds are highly valuable because of their unique chemical and physical properties, such as variable oxidation states, complex formation, and versatile bonding. These features make them essential in a wide range of applications, including biological systems, medical treatments, industrial process, and advanced material. So their use not only improves efficiency and performance, but also drives innovation and supports sustainable practice in modern science and technology.
All group members have researched a lot in the makings of this video. These are all the references. Well, all good things must come to an end. Many thanks to all the members that have collaborated successfully in this video. Many thanks to also you, the viewers, watching this video. So if you like this video, consider liking and sharing, and maybe subscribe. It helps a ton. But until then, stay tuned and wait for more videos like this. Thank you very much.